I just had to let you know you're. She a happy baby, she a happy baby.
Hi guys, my name is Muhammad Din Hafibi Fairuz, ID 2024261164. I will represent questions 2.
Hello everyone, my name is Ahmad Aiman Termizi bin Muhammad Firdaus. My ID is 2025896596, and today I will be presenting question number 1 and question number 3. Okay, to start off, the first question is, what is differentiation? Differentiation is a mathematical method used to find the instantaneous rate of change of a function which geometrically represents the exact slope gradient of a curve at any given point. In contrast to simple algebra, which calculates the average speed or slope between two separate points, differentiation zooms in infinitely close to a single point to reveal how fast a variable is changing at the exact millisecond. In total, there are about 6 techniques of differentiation. The first technique is derivatives of constant, linear, and power. The second technique is derivatives of sums and differences, while the third technique is product rule. For the fourth technique, it is derivatives of trigonometric, exponential, and logarithmic functions. And for the fifth technique, it is the chain rule. And last but not least, the last technique is quotient rule.
We are asked to find the derivative of the function y equal to 3x power of 2 cos x in bracket x plus 2. To solve this, we'll break it down into 4 simple steps. First step, we look at our fundamental calculus rules. Since our function consists of 2 different terms multiplied together, an algebraic term and a trigonometric term, we know we need to use the product rule. In step 2, we identify our piece. We let u equal the first part, which 3x power of 2, and let u equal the second part, which is cos x in bracket x plus 2. For step 3, we apply the rule. We take u, which is 3x power of 2, and multiply it by the derivative of v. The derivative of cos x is negative cos x, giving us the negative cos x in bracket x plus 2, cot in bracket x plus 2. Then we add v, which is cos x in bracket x plus 2 multiplied by the derivative of u, which is simply 6x. Finally, in step 4, we simplify our answer by factoring out the common terms. Both parts share a 3x and cos x in bracket x plus 2. Once we pull those out, we are left with our final derivative in step 4.
Moving on to the next question, which is question number 3. Our task here is to find dy over dx using implicit differentiation for the equation below, which is y ln of 3x minus e to the power of 2x plus 1 minus tangent of 4y, which equals to 0. Now let's take a closer look at the formulas we will be using to solve question number 3. To start with, the first formula is the implicit differentiation formula as shown on the slide, which is d over dx open bracket f of fy close bracket equals d over dy open bracket f of fy close bracket times dy over dx. For the next formula, we will be using product rule, which is d over dx open bracket u times v close bracket equals u times dv over dx plus v times du over dx. An easier way to memorize this is simply uv prime plus vu prime. Before we jump into the math, the first step is to separately differentiate each term with respect to x. Let's break it down term by term. First, let's handle the trickiest piece, which is y ln of 3x. We set u equals to y and v equals to ln of 3x. The derivative of u with respect to x is simply dy over dx, while the derivative of v is 1 over 3x times 3, which simplifies cleanly to 1 over x. Applying the product rule formula, this first term gives us y over x plus ln of 3x times dy over dx. Now for the second term, minus e to the power of 2x plus 1. This is a straightforward exponential derivative with respect to x. We differentiate the exponent to get 2 and bring it to the front, giving us minus 2 e to the power of 2x plus 1. Finally, the third term is minus tangent of 4y. Since this is a function of y, the derivative of tangent is secant squared, and the derivative of the inner layer for y is 4. Because of implicit differentiation, we must attach dy over dx. This gives us minus 4 secant squared of 4y times dy over dx. Now, moving to the second step, let's gather all our pieces and put them back into the main equation. Y over x plus ln of 3x times dy over dx minus 2 e to the power of 2x plus 1 minus 4 secant squared of 4y times dy over dx, which equals to 0. By factoring out dy over dx on the left, we get dy over dx open bracket ln of 3x minus 4 secant squared of 4y close bracket equals 2 e to the power of 2x plus 1 minus y over x. For the final touch, we isolate dy over dx completely by dividing both sides by the expression in the bracket. This leaves us with our final answer. Dy over dx equals a fraction. On the top, we have 2 e to the power of 2x plus 1 minus y over x. And on the bottom, we have ln of 3x minus 4 secant squared of 4y. And that is how we successfully solve question number 3 by using implicit differentiation. Thank you.
Alright, so now we are at question 4. For the question 4, our question is use linear approximation to estimate the following values to 4 decimal places. Our question is square root 169 minus 4.9 in parentheses in the power of 2. So, as the question state, use linear approximation. So when they say use linear approximation, we already know the formula that we need to use as stated below. The linear approximation formula, fx equal fa plus f prime a in parentheses x minus a. So let's move on. Alright, so for the solution, for the step 1, we need to define the function and the center point. Based on the expression that we have, we can define our function as fx equal square root 169 minus x power of 2. Since the x for our expression is 4.9, we need to pick the center point. For the center point, we need to pick the closest one to the x, so that we can calculate it easier even without using calculator. So for this one, I pick x equal 5 as the center point. Alright, for step 2, we need to calculate FA. So what we need to do is we plug x equal 5 that I had earlier. So as we substitute the x with 5, as you guys can see, as we done it one by one, we will get that FA is equal to 12. Okay, moving on to step 3, we need to find the derivative, which is f prime x. We can find the derivative using the chain rule. So as you guys can see, we are using chain rule to find the derivative. F prime x equal 1 over 2, 169 minus x squared with the power of negative 1 over 2 multiplied by negative 2x. So the derivative that we found is f prime x equal negative x over square root 169 minus x power of 2. So let's move on. Alright, for step 4, we need to evaluate the derivative at a equal 5. So using the derivative that we found earlier, just substitute the x with 5, just like we did earlier with the fa. So as you guys can see, substitute the x with 5. So our final answer for the f prime a is equal to negative 5 over 12. Alright, now moving on to step 5. Okay, this one we just need to apply the linear approximation formula. We just need to substitute everything that we found into the formula. So for the FA, but before that, we need to make sure A is equal 4.9 and X is equal to 5. For the FA, earlier we got 12, and for the F prime A, we got negative 5 over 12. So just substitute it as usual. We complete it one by one, and then we will get 12 plus 1 over 24. Alright. Okay, this one is simple. Just complete it, and then we will get 12.041666. But since the question asks us for 4 decimal pieces, we are going to round it up by 4 decimal pieces. So our final answer is 12.04117. Alright, that's pretty much wraps up for question 4.
I just had to let you know you're